Welcome to our discussion on a crucial aspect of mathematics that underpins many concepts in AI and machine learning, linear algebra, specifically focusing on vectors and matrices. First, let's talk about vectors. A vector is essentially an ordered list of numbers. Each number in a vector can represent a specific quantity, allowing us to describe not just magnitude but also direction. For example, in a 3D space, a vector could represent a point's location with respect to the origin, showing how far it is along each of the axes. Next, we have matrices, which are rectangular arrays of numbers. Think of a matrix as a way to organize data efficiently. Each element in a matrix can represent a different piece of information, and matrices are incredibly useful in performing mathematical operations that can transform data. When it comes to operations, vectors and matrices can be added, subtracted, and multiplied following specific rules. These operations help us manipulate data in various ways, such as combining datasets or applying transformations. The applications of vectors and matrices in machine learning are vast. They form the backbone of how we represent data. For instance, when we input features into a machine learning model, we often represent these features as vectors. Similarly, matrices can be used to represent datasets, where each row corresponds to a data point and each column corresponds to a feature. Finally, let's touch on the geometric interpretation of these concepts. Vectors can be visualized as arrows pointing in space, indicating direction and distance. Matrices can transform these vectors, changing their position, orientation, or scale. This geometric understanding is essential when we consider how algorithms manipulate data in machine learning. In summary, vectors and matrices are foundational in linear algebra and play a vital role in the field of AI and machine learning. Understanding these concepts allows us to harness the power of data effectively.